Hello everyone. In this video we're going to be solving a really nice system of equations with radicals. A radical system of equations. We have x plus the square root of 1 minus y squared equals 1 and y plus the square root of 1 minus x squared equals the square root of 3, which is another radical, and we're going to be solving for x and y values. Well, it would be nice, I think, if I included a graph of these two functions or relations so that you can look at the intersection points, but I'm too lazy and I also forget about it. Anyways, so hopefully you can do this with Desmos and share with us some links. Now, to be able to solve this problem, I'm going to be using two different approaches. I'm hoping that you're going to like the second one better. But again, it's up to you. You're going to let us know, right? Okay, great. So let's go ahead and start with the first method for this radical system. I'm going to go ahead and start with the first equation. Let me rewrite it. X plus the square root of 1 minus y squared equals 1. I want to isolate the radical. Let's go ahead and subtract x from both sides. And of course, my next obvious step is what? Squaring both sides, right? If you square both sides, you get rid of the radicals, which is good. 1 minus y squared equals 1 plus x squared minus 2x. Great. That is the formula for a minus b, which is something you need to know. A minus b squared, sorry. 1 cancels out, which is a good thing. And then from here, we get something interesting. So you got to decide like which variable you would like to isolate, right? And if you think about it, isolating y would probably be a little easier. So let me show you. From here, we get y squared equals 2x minus x squared if you kind of switch sides. Not switch sides, but switch terms, in other words. And then from here, we get two options. Y can be the square root of 2x minus x squared, or y can be the opposite of that. Because obviously, there are two numbers whose square equals 2x minus x squared, and these are the numbers. And which one are we going to use? I want to use the first one, the more positive one, okay? Now, are we going to substitute that into the second equation? Let's go ahead and actually do the same thing and see what we can do. Maybe something better will come up. Again, we're going to be isolating the radical here. So square root of 1 minus x squared is equal to square root of 3 minus y. And then we'll square both sides. And then this will give us 1 minus x squared equals 3 plus y squared minus 2 root 3y. The ones don't cancel out in this case, but you hopefully notice that we have the x squared and we have the y squared in this equation. So one thing you can do is you can actually put everything on the same side. So it looks like this, x squared plus y squared minus 2 root 3y. If you want to leave the 1 alone, along with the 3, that's fine. Or you can just add the 2 at the end. Okay, so that's my second equation. And I got rid of the radical. But here's the thing. Can we completely get rid of the radicals? Well, if you consider the first equation before I took the square root, I got y squared equals 2x minus x squared. So I got this and I got that. Can I do something with these, right? Well, sort of. The problem here is I have a y squared. Yes, I can replace it with this completely, but I also have a y. So I have to use the square root of this expression. And that's going to make a difference because it's going to give us two different equations. Let's try the first one with the positive approach. X squared plus y squared, I'm going to replace with 2x minus x squared. Minus 2 root 3y. Y has to be replaced with this one or that one. Unfortunately, that's going to give us another radical, which we have to get rid of. So this is y. And then plus 2 equals 0. X squared cancels out, so that's kind of like a good thing. Looks like everything is divisible by 2. So I can go ahead and divide x minus root 3 times this expression. We could also put those two together and so on and so forth. And of course, in this case, it would make sense. Leave the x plus 1 here and multiply these together and put them on the other side, 6x minus 3x squared. So in other words, I distributed the 3 here inside, okay? Great. So let's go ahead and square both sides one more time, yeah? And that gives us x squared plus 1 plus 2x. And I always write a squared plus b squared first. That is equal to 6x minus 3x squared. Put everything on the left-hand side. You get 4x squared. Subtract minus 4x plus 1 equals 0. Beautiful. This is a really nice equation because this is a perfect square. You should be able to recognize these to 2x minus 1 quantity squared. From here we get 2x minus 1 equals 0 or x equals 1/2. Great. It's great that we got a unique solution, but we still have to check. Of course, this is just one branch, and you can do the other branch similarly. But x equals 1/2, I'm hoping that will work, okay? And what you can do next is basically you have an equation for y squared, which is 2x minus x squared. So you can go ahead and plug in 1/2. This will give you 1 minus 1/4, which is 3/4. And from here, y will be plus minus root 3 over 2. I want you to remember those values. If you need it, take note. Because when we do the second method, these values are going to come up. And hopefully you're going to recognize, this is what it meant, right? Maybe even at this point, you were able to recognize these special values. Okay, did I give away too much? Hopefully not, because we're about to start the second method. Okay, great. For our second method, we're going to be using an entirely different approach, thanks to trigonometry. Okay, great. That is the method, and here's how it works, and here's why it works. First of all, let me explain that. In order for this to be well-defined, like in order for us to have real solutions, we need two conditions. Anything under the radical needs to be greater or equal to 0. So in other words, 1 minus y squared needs to be greater than or equal to 0. 1 minus x squared needs to be greater or equal to 0. But this just means that y needs to be between -1 and 1. As you know, you can factor or do some other way. Square roots are fine, but you have to use absolute value. So we need to have these two conditions. And this is kind of like an and condition, right? They both have to be true. What does this mean, though? Well, this just means that we can use trigonometric substitution. Why? Because think about it. If x is sine of theta and y is cosine of beta. And by the way, why did I use different angles? Because we don't know if x and y are related in such a way that x squared plus y squared equals 1, right? We don't have that. But the only thing we have is the system, and it works. So x and y are different angles, or sine and cosine of different angles. Let's go ahead and plug it in and see what happens. If you replace x with sine theta, by the way, you could also use alpha and beta, I guess. Why not? Alpha and beta make more sense. So let's say x is sine alpha, y is cosine beta. If you replace x with sine alpha, it's going to give you sine alpha plus, now the square root of 1 minus y squared. That'll be 1 minus cosine squared beta, and you need to know this from Pythagorean identity, that this is equal to sine squared. Its square root is going to be plus minus sine beta. Let me show you the plus version. Again, you can go with the other version. So let's go ahead and turn this into sine alpha plus sine beta equals 1. So far, so good? Okay, great. And if you do the second, the substitution into the second equation, you're going to get y first, which is cosine beta. And then, of course, the other one is going to be cosine alpha. If you go with the positive solution again, you can kind of look at the different branches. And this is the type of system we're getting. Again, this is nice, but how do you solve a trigonometric system like this, right? Well, there's two options. You can use sum to product formulas. Do you know them? Well, they kind of involve stuff like 2 times, sine of alpha plus beta over 2 times sine of alpha minus beta over 2, so on and so forth, something like that. Or the other variations, obviously. And once you get that, you can divide by side. You'll get the tangent, so on and so forth. So that's one way to look at it. But there's a better way to look at this, which I really like, and I'm hoping that it's going to work better. Let's go ahead and experiment. I don't know, because I haven't tried it yet, but I have a feeling this is going to work. So let's go ahead and square both sides on both of these equations. And the good thing about it, you'll see now, sine squared alpha plus sine squared beta plus 2 sine alpha sine beta is equal to 1. And from the second equation, we get cosine squared beta plus cosine squared alpha plus 2 cosine beta cosine alpha is equal to 3. Great. Now, it's going to be greater when you add these two equations because sine squared alpha plus cosine squared alpha is 1. This is also 1. 1 plus 1 is equal to 2. We get 2 times, or 2 plus 2 times the quantity. Let's go ahead and factor out the 2 here, cosine beta, cosine alpha, plus sine beta, sine alpha is equal to 4. You can subtract 2 from both sides and then divide, and it'll give you the following. Cosine beta, cosine alpha, plus sine beta, sine alpha is equal to 1. Beautiful. But what makes it even better is that the expression on the left-hand side, coming from the sum and difference formulas, is equal to cosine beta minus alpha. You got to remember that with the cosine formulas, things are a little weird. It's the opposite sign. So if you have a minus sign, it turns into a plus sign and vice versa. So now this is what we have so far. Great. So what do we have? We have cosine beta minus alpha, right, is equal to 1. So from here we can extrapolate and say, maybe beta minus alpha is equal to something we know. When the cosine of which angle is equal to 1? Pi over 2, right? Exactly. So from here we can safely say that, hey, beta minus alpha is equal to pi over 2, or this means beta is equal to pi over 2 plus alpha. Okay, we were able to express beta in terms of alpha, which is a good thing. Now let's go back and check what we substituted for. We said that, okay, x is equal to sine alpha, and we said y is equal to sine beta, right? Was it sine or cosine? Okay, and again, I don't know why I didn't pick sine for both of them. I just picked sine and cosine. Again, no idea. I guess I want to bring the signs together. But again, if you picked sine beta here, it would still be good. But why is cosine beta? Okay, great. And what do we know? Beta is pi over 2 plus alpha. So if you replace beta with pi over 2 plus alpha, this is what you get. And what is cosine pi over 2 plus alpha? You see, here's what you need to think about. Suppose alpha is an acute angle, and by the way, even if alpha isn't acute, this works. When you add pi over 2 to it, you're basically going to flip it like this. You're going to add pi over 2 to it, which is 90. It's basically going to switch sine and cosine values. But it's also going to put you in the second quadrant where cosine is negative. So you're going to have to put a minus sign here and then change the name to sine alpha. Wow, that's great, isn't it? This means y is negative sine alpha. How is that helpful? Well, x is sine alpha, y is negative sine alpha. What is that supposed to mean? That means x plus y is equal to 0, right? Well, at least for certain values of x and y. But is that possible at all? Well, if that's the case, let's find out. For example, let's just take the first equation. X plus the square root of 1 minus y squared is equal to 1. From here, if y can be replaced with negative x, from here we get x plus 1 minus x squared. And then by getting rid of the radicals, or we could use one of these equations we used before, same idea. Let's go ahead and square both sides one more time. But this time we only have x, which is nice. This gives us 1 plus x squared minus 2x. 1 cancels out. We get x squared, 2x squared minus 2x is equal to 0. From here, 2x times x minus 1 equals 0. So either x is 0 or x is equal to 1. You know what? I have a feeling that I probably made a mistake because I didn't get x equals 1/2. I was supposed to get x equals 1/2. So let me go ahead and check my work. Why did I get something else? And by the way, there's a way, because we found this with the first method, right? There's actually a way for you to check your work. Let's just plug it in real quick. I think it's going to work because we already got it from there. 1 minus 3/4 is 1/4, 1/2. Okay. Looks like these values are working. So why did we, or where did we mess up? I think x plus y is probably, x plus y equals 0 is probably a mistake. That should be something else. Oh, you know what? This doesn't have to be true, because if cosine beta minus alpha is equal to 1, this could also be, this could also mean, actually, the only thing that matters is, let's see. Yeah, something is off here. I don't know exactly what it is, but I got this so far. Anyways, hopefully you're going to figure it out. My first method is still valid. Go ahead and let me know why we got x equals 1 here, because I can't figure it out at this point. This brings us to the end of this video. Thanks for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe, take care, and bye-bye.